Welcome, everyone, to another deep dive. We're about to explore a world that's often hidden in plain sight, the fascinating realm of fungi. I'm really excited about this one. You sent over a really interesting textbook chapter, and I can't wait to unpack it with you and unearth some serious fungal knowledge.
I'm ready to dig in. Fungi are full of surprises. It's a captivating kingdom, that's for sure.
So right off the bat, this chapter hits us with a real shocker. You ready for this? For the longest time, scientists actually thought fungi were plants. I mean, I get it. They kind of resemble plants in a way, don't they?
Yeah, it's totally understandable. They don't move around like animals, and they seem to pop up from the ground like plants, right? But that's the thing about appearances, they can be deceiving. This chapter really dives into how molecular analysis has changed our understanding of fungi. Turns out they're actually more closely related to us, to animals, than to plants.
Right. Talk about a plot twist. It really makes you think twice when you see a mushroom, doesn't it? That portobello on your pizza is practically family. So what led to this major scientific shakeup?
Well, back in the day, scientists relied mostly on what they could observe. But then came DNA analysis, and boom, suddenly we could look at the very blueprint of life. That's when we discovered this deep evolutionary link. Turns out fungi and animals diverged from a common ancestor way back about 450 million years ago.
Wow, 450 million years.
Yeah.
That's one long-lost family reunion. But, speaking of appearances, whenever I see a mushroom, I always have to remind myself it's just the tip of the iceberg, right? The chapter talks about this mind-blowing network underground, the mycelium. What's going on down there?
Picture this, a massive, intricate web of tiny, delicate threads spreading beneath the surface, weaving through the soil, under leaves, even inside decaying wood. That's the mycelium, an incredible network of hyphae, and the way it grows and eats is just fascinating.
Okay, so how does something that looks so delicate, just threads basically, manage to, well, eat and grow into something as big as a mushroom?
Imagine having your stomach on the outside.
Whoa, what?
Yeah, so fungi release digestive enzymes into their environment, breaking down organic matter externally before absorbing the nutrients. It's incredibly efficient and makes them really good at their job as decomposers.
External stomachs.
Mm.
That's going to be stuck in my head now.
Mhm.
And talk about incredible, the chapter mentions a honey mushroom in Oregon that covers over 2,000 acres. One giant organism.
Yeah, it really shows you how interconnected these fungal networks can be. That honey mushroom is considered the largest organism on Earth, and they estimate it to be at least 2,400 years old. It's amazing, just a small glimpse of the size and complexity that we don't usually see.
It really makes you wonder what's happening beneath our feet, right? All these fungal networks quietly doing their thing. And speaking of doing their thing, let's talk about how these fascinating organisms reproduce. The chapter mentions spores, trillions of them, released from a single mushroom.
Trillions. It's mind-boggling, right? A giant puffball mushroom can release that many. And each spore is like a tiny traveler, carrying the potential to start a new colony. They're incredibly resilient, too, able to handle tough conditions, lie dormant for ages, and then boom, the perfect conditions hit, and they're ready to sprout.
Wow, it's like winning the lottery, but on a microscopic level, huh? Finding that perfect spot to grow. So how does it all work? Is it all about these spores?
Spores are definitely a big part of it, but there are two main ways fungi reproduce: sexually and asexually.
Ooh, 2 for 1. Tell me more.
So, asexual reproduction is all about efficiency. Allows fungi to spread quickly in good conditions. It can be as simple as a piece of the mycelium breaking off and starting a new colony, but it's the sexual reproduction in fungi that's really cool. This involves the fusion of hyphae from different mating types, which creates genetic diversity, kind of like shuffling a deck of cards, so fungi can adapt to new and changing environments.
Genetic diversity, right? So it's like with animals then, mixing things up helps create stronger offspring that can handle whatever comes their way.
Precisely. And those spores we were talking about, carried by the wind and sometimes water, are the products of this intricate dance of reproduction. They ensure that fungi can survive and thrive across different ecosystems.
It's really amazing, this whole network of activity going on beneath our feet. But fungi aren't just content staying underground, are they? This chapter really opened my eyes to the huge role fungi play in our lives, for better or for worse.
Yeah, for sure. They're both our allies and our, well, let's just say not so friendly roommates in this world.
Right. It's a bit of a love-hate relationship, I guess you could say. Like, for every tasty loaf of bread we owe to yeast, there's a potential fungal infection just waiting for a chance.
It's all about balance, right? But let's focus on the good stuff first. I mean, think about it. Fungi have been essential to our food for centuries. Yeast, for instance, has been our partner in creating all sorts of culinary delights. bread, cheese, even those celebratory drinks we all love.
Oh, and don't even get me started on blue cheese. It's amazing. I admit I used to be a bit, wary of it, but once I learned it's just penicillin working its magic. And speaking of penicillin, we got to talk about penicillin, right? Okay. The chapter really emphasizes how its discovery totally transformed medicine. It's pretty mind-blowing to think that this simple fungus held the key to combating bacterial infections that were once a death sentence.
Absolutely. Penicillin's impact is immeasurable. It really ushered in this whole new era of antibiotics. And you know what's interesting? The chapter mentions that a lot of our antibiotics actually come from fungi.
Really? I had no idea.
It's like a constant arms race happening in the microbial world. Fungi versus bacteria, fighting for resources, and fungi, well, they've developed some pretty amazing chemical defenses over time. We've basically tapped into this ancient battle and used it to our advantage.
That's incredible how these tiny organisms have literally changed the course of human history. But like you said earlier, it's not always smooth sailing, right? There's a flip side to this coin. The chapter also talks about the diseases fungi can cause, both in plants and in us.
Right. Unfortunately, fungi can be quite devastating too. Dut elm disease is a prime example. This fungal pathogen, spread by bark beetles, has really wreaked havoc on elm populations, especially here in North America.
It's heartbreaking, isn't it? Those magnificent elms brought down by a fungus. And then there are the effects on humans, too. I have a confession. I've had more battles with athlete's foot than I care to admit. It's like a constant reminder that fungi are always around, even on us.
Athlete's foot, ringworm, those pesky yeast infections, they're all reminders of that, yeah. And while most fungal infections are more annoying than anything else, some can be quite dangerous, especially for people with weakened immune systems.
It definitely makes you realize that we need to respect the power of these organisms, even though we've made amazing progress in medicine, thanks in part to them. But enough of the doom and gloom. The chapter wraps up on a more positive note, highlighting the huge potential fungi hold for tackling some of our biggest global challenges.
And that's something that gets me really excited. The possibilities seem endless. It feels like we're just scratching the surface with fungal biotechnology.
On all ears, what's got you so fired up about the future of fungi?
One area that's really promising is mycoremediation, basically using fungi to clean up messes. And I'm not talking about a little spill on the counter. I'm talking polluted environments.
Right, like a fungal superhero squad swooping in to save the day.
Exactly. Certain fungi, they can break down some seriously nasty stuff, things we humans consider super tough to get rid of, like diesel fuel, heavy metals, even pesticides.
It's like they have these microscopic hazmat suits and they're not even phased. So this isn't just like a theory, right? This is actually being used now.
Oh, yeah, totally. There are projects happening all over the world using fungi to clean up oil spills, contaminated sites, even pulling heavy metals from polluted water. It's incredible how they can thrive in those environments.
It makes sense though, right? If they can break down a giant fallen tree, imagine what they could do with our pollution. And speaking of breaking stuff down, the chapter mentioned using fungi to create building materials. It sounds kind of crazy.
I know, right? But it's becoming a reality. Turns out you can grow these mycelium-based materials into all sorts of shapes and densities. They can be used as a sustainable alternative to things like plastic, styrofoam, even certain construction materials.
So wait, are you saying that one day we could have houses built with mushrooms?
It's not as far-fetched as it sounds. They're already using mycelium bricks in construction, and some companies are even developing insulation, packaging, furniture, all made from fungi.
That's amazing. It's so cool that we're finding these innovative, sustainable solutions inspired by nature. And while we're on the topic of innovation, the chapter also mentioned fungi being used in medicine beyond antibiotics too, right?
Oh, yeah. Researchers are discovering new medicinal compounds in fungi all the time. We're talking about potential new ways to treat cancer, fight viruses, even tackle neurological disorders. It's a really exciting field, that's for sure.
It just goes to show how much we still have to learn from these incredible organisms. They've been around for millions of years, quietly shaping our world.
Exactly. It's humbling, isn't it? For so long, fungi were kind of overlooked, but now we're starting to realize just how vital they are to, well, pretty much everything.
That's a good way to put it. This whole deep dive has been a real eye-opener for me. I'll never look at a mushroom the same way again.
And that's the power of knowledge, right? Expanding our understanding of the world around us, even the parts we can't always see.
Absolutely. Well, as we wrap up this fungal adventure, I want to leave our listeners with a final thought. If fungi can break down some of the toughest pollutants, like we've been talking about, could they hold the key to something even bigger? Something like cleaning up plastic waste? It's a question worth pondering.
It really is, and it speaks to the incredible ongoing exploration of fungi's capabilities. Who knows what other mysteries and amazing potential are still out there just waiting to be discovered. It's an exciting time to be, well, a fungi fan.
It certainly is. Thanks for joining me on this incredible journey to the often hidden kingdom of fungi. Until next time, keep exploring, everyone, and remember, sometimes the most fascinating discoveries are right under our feet.